Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. Before starting our today's topic, please, my dear students, subscribe my channel. So, my dear students, today's topic for the lecture is a limiting reactant along with some numericals. So, let us understand what is exactly the limiting reactant. My dear students, as we all know that in a chemical reaction, reactants react with each other to give products. So obviously the reactant which will get completely consumed in a reaction very first comparatively other reactant due to which the reaction stops is called limiting reactant. So my dear student, I'm writing what is the limiting reactant in a chemical reaction. In a chemical reaction, reactants always reacts with each other, always reacts with each other to give products, to give products. So the reactant which will get completely consumed first, the reactant which will completely consumed first. So the reactant which will completely consumed first. Comparatively other reactants comparatively other reactants due to which what will happen, due to which chemical reaction stops, due to which chemical reaction stops. So that reactant is called limiting reactant. That reactant is called limiting reactant. Now, what next? My dear students, the consumption of the reactants is always taken in number of moles. It is always measured in the number of moles. So what next I'm writing? The consumption of any reactant, the consumption of any reactant or even formation of products, or even formation of products is always evaluated, is always evaluated in number of moles. And for that evaluation, for that evaluation, for this evaluation, you must have, you must have, or you must balance your chemical reaction first. You must balance the chemical reaction. If you will balance the chemical reaction, only then you will get the correct relationships of reactant with each other and with that of products according to their number of moles. So the first criteria to find out a limiting reactant is that you must have the balanced chemical reaction. Now, what next? The next is the quantity of product formed. The quantity of product formed is always measured is always measured with respect to the quantity of limiting reactant. Quantity of limiting reactant which was completely consumed. Which was completely consumed in a reaction. Because once that quantity of limiting reactant is consumed, the reaction stops. If the reaction stops, obviously the formation of product will stop. So the quantity of product formed is always measured with the respect to the quantity of limiting reactant which was completely consumed in a chemical reaction. In a chemical reaction. So this was the limiting reactant. I hope you all understood it. You will have the better clearance of limiting reactant when we will attempt the different numericals. So let's come to the numericals. Now, what's the first numerical is saying? It's saying you are having 3 gram of hydrogen reacts with 29 grams of O2 to yield water. I have to evaluate the limiting reactant, the maximum amount of H2O that have been formed, and I also have to calculate the amount of reactant which remains unreacted. Let's come back to our topic. Here I have told you that the quantity of limiting reactant is completely consumed. So what about the other reactants then? Let's talk about the other reactants. Once the limiting reactant is consumed, the other reactants, the other reactants of the reactant of the reaction, the other reactants of the reaction left unreacted. And in some numericals, even we also have to find the quantity of other reactants which have been left unreacted. So that was my point for today. So let's come back to our numerical. First of all, my first rule that I have told you, you have to write the balanced chemical reaction. So I'm writing, my dear students, is an H2 plus O2 and gonna form me H2O. So now balance it. It's 2H2, it's 2H2O. Now it's a balanced chemical reaction. Now let's talk about the given weights. What's the weight of hydrogen given over here? 3 gram of hydrogen. So it's a 3 grams of hydrogen. And what's that of oxygen? Is 29 gram of oxygen. So I'm writing 29 grams of oxygen. So my dear students, it's a given weight of the question. So I'm representing both as capital W. Now let's write the molecular weights of H2 and O2. For H2 the molecular weight is 2 grams and for oxygen The atomic mass of one oxygen is 16. It's 16, but we are having two oxygen, so it comes out to be 32 grams. So the molecular weight of oxygen comes out to be 32 grams. So now let's evaluate their number of moles. Number of moles are evaluated by using the term given weight divided by molecular weight. Now given weight of hydrogen is 3 over here in this question, and its molecular weight is 2. That of oxygen is 29. The molecular weight of oxygen is 32. So it comes out to be, the number of moles comes out to be, number of moles are represented by small n, so I have taken small n. It comes out to be 1.5, and that of 29 divided by 32, it comes out to be 0.9. So I have evaluated the number of moles of H2 and O2 that have been given in the question. Now I have to evaluate the limiting reactant. So let's come back to the reaction. What this reaction is stating? It states that the balanced chemical reaction states that 2 moles of hydrogen reacts with 1 mole of oxygen. That's the term I have got from the balanced chemical equation, that 2 moles of hydrogen reacts with 1 mole of oxygen. You can write here reacts with 1 mole of oxygen. Now, how many moles of hydrogen are given in the question? It have been given to be 1.5. So now let's calculate 1.5 mole of hydrogen will require how much moles of oxygen? So my question is, then 1.5 mole of hydrogen will require how much moles of oxygen? That will be obviously 1 divided by 2 into 1.5 moles of oxygen, and it comes out to be 0.75 moles of oxygen. 0.75 moles of oxygen. So 1.5 mole of hydrogen will require 0.75 mole of O2. Now my dear students, compare this thing. What comparison? 1.5 mole of H2 requires 0.5 mole of O2. But in numerical, in question, we are available with 0.9 mole of oxygen. We were in the requirement of 0.75, but we are having 0.9 mole of oxygen. That means in the given quantities, we are having excess of oxygen. Hopefully, my dear students, you got it. 1.5 mole of hydrogen, 1.5 mole of hydrogen requires 0.75 mole of oxygen, but we are available with 0.9. That means oxygen is excess. So my limiting reactant comes out to be hydrogen only, because hydrogen will get extinguished or get vanished or get completed first, then the oxygen. So my limiting reactant comes out to be hydrogen. So in this case, limiting reactant comes out to be hydrogen gas. Hopefully, my dear students, you got it. What I have evaluated, the number of moles of hydrogen in the question, it's 1.5. Then I have evaluated according to the balanced chemical equation that 1.5 mole of hydrogen will require 0.75 mole of O2. But in the question we were available with 0.9 mole of O2. That means we were having the excess of oxygen. Then vice versa, hydrogen will act as limiting reactant because it will get consumed first. So I got my limiting reactant to be hydrogen. So I'm coming back to question. My first question is completed, that I have found out the limiting reactant. Now the second question, calculate the amount of H2O that can be formed. So now with the help of chemical reaction, I will evaluate the quantity of H2O that is formed. I'm deleting something. Now I got my limiting reactant to be hydrogen. That's my hydrogen limiting reactant. And accordingly this, I will evaluate the quantity of water. Now just have a close look over here, that 2 moles of hydrogen produces 2 moles of H2O. According to limiting reactant, I have to take this equation, that 2 mole of H2 produce 2 mole of H2O, because limiting reactant is H2 and I have taken the balanced chemical equation. So I'm coming back to my evaluation part downstairs. So I'm writing my second part. I'm writing that 2 mole of H2 produces 2 moles of H2O. That means how many moles of H2 were given in the question? They were the 1.5. Please have a close look. The number of moles of H2 given in the question were 1.5. So 1.5 moles of H2 will produce obviously same 1.5 mole of H2O. So I got the 1.5 mole of H2O. So the number of moles of H2O that will be produced in the reaction in this case will be 1.5. So now what next? The number of moles of H2O will be the weight of H2O divided by molecular mass of H2O, that will be equal to the 1.5. We all know that the molecular mass of H2O is always 18. I have done so many numericals by taking the mass of H2O to be 18 in the previous videos. I hope you understood it. It comes out to be 1.5. So the weight of H2O produced is 1.5 into 18, and it comes out to be 27 grams. So I got my answer to be 27 grams. So this was my second part. Now I got this answer to be 27 grams, my limiting reactant to be H2. Now what's the third question? Calculate the amount of reactant which remains unreacted. Now which reactant was in excess? My dear students, which reactant was in excess? It was O2. My O2 was in excess because the requirement was of 0.75 moles, but I was available with 0.9 moles. So obviously excess was O2. So I have to evaluate how much amount of O2 is left unreacted. That's my third part. So I'm evaluating it. I'm evaluating my third question. I'm writing first of all that O2 was in excess in this question. O2 was in excess. So number of moles of O2 unreacted, that will be equal to the my available number of moles were 0.9. The consumed number of moles of O2 were 0.75. So the number of moles of O2 unreacted were 0.15 moles of O2 left unreacted. Left unreacted. So it is obviously weight of O2 divided by molecular mass of O2 to be 0.15. So it comes out to be weight of O2 comes out to be 0.15. The molecular mass of O2 comes out to be 32, and it comes out to be 4.8 gram of O2 was left unreacted out of 29 grams of O2. So it comes out to be, third part comes out to be 4.8 grams. So this was my question. Hopefully my dear students, you got the first numerical. It was the easy and the simple one, but totally on the IQ. Just listen to my lecture very carefully. So I'm coming to the next numerical. In the next numerical, he is saying 500 ml of 0.25 molar Na2SO4 is added to an aqueous solution of 15 grams of barium chloride, resulting in the formation of white precipitate of barium sulfate. How many moles and how many grams of barium sulfate are formed? That means I have to evaluate the quantity of product. Whenever you have to evaluate the quantity of product in a chemical reaction, you firstly always have to calculate the limiting reactant. So the quantity of limiting reactant consumed will give you the exact quantity of product that will be formed. So first of all, I'm writing the chemical reaction for this case first. My chemical reaction between Na2SO4 and barium chloride. So I'm writing my Na2SO4 reacts with barium chloride to form me barium sulfate and sodium chloride. So my dear students, first of all we have to balance our chemical reaction, and it is already balanced. Now I have to calculate the number of moles of Na2SO4 and a barium chloride from the data given in the question. So let's calculate it first. Now he is saying we are having, let's see the question first, that we are having 500 ml of 0.25 molar solution, that we are having 500 ml of 0.25 molar solution. First of all, I have to calculate the number of moles in this solution. So we all know that the formula for molarity is number of moles of solid divided by volume of solution. If volume is in ml, I have to multiply with 1000. So my molarity is, in the question given, is 0.2 molar. Number of moles I have to evaluate. My volume is 500 into 1000. So my dear students, number of moles comes out to be 0.125. That's the number of moles of Na2SO4 that have been given in the question. Now let's talk about barium chloride now. The barium chloride, 15 grams of barium chloride. The given weight of barium chloride is 15 grams. Now let's calculate the molecular mass of barium chloride. The molecular mass of barium chloride, the atomic mass of barium is 137 plus the atomic mass of 1 chlorine is 35.5 into 2, and it comes out to be 208. So the number of moles are obviously given weight by molecular weight. It comes out to be 15 divided by 208. Now the number of moles of barium chloride comes out to be 0.0721. So hopefully my dear students, you got it. I have calculated number of moles of Na2SO4 and that of barium chloride. But these two were different methods of calculating number of moles according to the data given in the question. So now what I have to do, I have to find a limiting reactant. So I will pick one concentration, let it be Na2SO4 first. So I'm coming to back to my reaction, sorry. In the reaction I can easily see that 1 mole of Na2SO4 reacts with 1 mole of barium chloride. So I will make an equation that 1 mole of Na2SO4 reacts with, I'm writing, reacts with 1 mole of barium chloride. My dear students, actually the molarity is there. In the chemical reaction, there is always molarity. I'm taking my net volume of solution to be 1 liter. So I'm directly taking my molarity to be equal to the number of moles. Please don't get confused. I have assumed my volume. I have assumed my volume to be 1 liter. So I'm directly taking the stoichiometry of the chemical reaction, that is this one, or the one that 1 mole of Na2SO4 reacts with 1 mole of barium chloride. I'm directly taking molarity to be the number of moles because I have assumed my volume to be 1 liter, and it's very easy method to find out a limiting reactant. Please don't get confused. So let's move forward. It says that like 1 mole of Na2SO4 reacts with 1 mole of barium chloride. So how much this mole will react with moles of barium chloride? Then 0.125 mole of Na2SO4 will react with, obviously, 0.125 mole of barium chloride, because both the moles were equal, 1 mole of Na2SO4 and 1 mole of barium chloride. So I've directly calculated like 0.125 mole of Na2SO4 will react with 0.125 mole of barium chloride. So now again carefully see the data. We were required 0.125 mole of barium chloride, but in question we were available with only 0.0721 mole of barium chloride. Now again say it that 0.125 moles of Na2SO4 requires 0.125 mole of barium chloride for complete reaction, but we are available with only 0.0721. That means according to the number of moles, barium chloride is less, so it will get vanished first, it will get consumed first. The 0.0721 moles will get consumed first, then Na2SO4. So obviously my limiting reactant comes out to be barium chloride. So here I'm writing limiting reactant, my limiting reactant comes out to be barium chloride. So what next? In the question he was asking how many moles and how many grams of barium sulfate will be formed. So obviously I will take the relationship between now the limiting reactant, which is barium chloride, and the barium sulfate, that is barium chloride and the barium sulfate. I will take the relationship of barium chloride and barium sulfate because barium chloride is limiting reactant. So again 1 mole of barium chloride, 1 mole of barium chloride produces 1 mole of barium sulfate. That's my chemical reaction. I'm coming back to my data now. I'm writing 1 mole of barium chloride produces 1 mole of barium sulfate. Now, how much quantity of barium chloride is given? That is 0.0721. I'm going to put it over here. Now, 0.0721 mole of barium chloride will give 0.0721 moles of barium sulfate. So I got my first answer is 0.0721. My number of moles comes out to be 0.0721. Now I have to evaluate its weight. Now the number of moles of barium sulfate produced will be 0.0721. Now number of moles is given weight, W divided by molecular weight comes out to be 0.0721. Now W divided by molecular weight. The molecular weight of barium sulfate, I'm writing the barium sulfate. The atomic mass of barium is 137. That of sulfur is 32. That of oxygen is 16 into 4, and it comes out to be W divided by my sum comes out to be 233. That's the number of moles is 0.0721, and my W comes out to be now 233 into 0.0721, and this value comes out to be my weight of barium sulfate found will be 16.77 grams. So that is my question. Hopefully my dear students you got it. So let's move to the third numerical. Now what's third numerical is saying now? Now 50 kilograms of N2 reacts with 10 kilograms of H2, and these both quantities are mixed to produce the NH3. Calculate the amount of NH3 formed. Again here I have to find the product, so I will find the limiting reactant first. So I'm writing first of all my balanced chemical reaction, N2 plus H2, it forms me NH3. Let's balance it first. N2 plus 3H2 forms me 2NH3. That's my balanced chemical reaction. Now what are the weights given? Given weights of N2 is, and the H2 is 50 kilograms, that of H2 is 10 kilograms. Now let's convert it to the grams. It's 50,000 grams, it's 10,000 grams. Now what are its molecular weights? The molecular weight of N2 is 14 into 2 comes out to be 28, and that of H2 is obviously 2. While calculating the molecular weights, please don't consider the stoichiometry of a chemical reaction. Please don't consider that. We have to take the molecular weight, that is the weight of only one molecule. Now let's calculate the number of moles. The number of moles is obviously given weight divided by molecular weight. It's 50,000. Molecular weight is 28, and this value comes out to be 1785 moles. Let's talk about H2 now. It's 10,000 divided by 2, and this comes out to be 5,000 moles. Now let's calculate our limiting reactant. Now just have a look of a reaction. Here you can see that 1 mole of N2 reacts with 3 moles of H2. Reacts with 3 moles of H2. So I'm using this relation. I'm writing that 1 mole of N2 reacts with 3 moles of H2. Now let's talk about N2. Then how much this moles of N2 will require how many moles of H2. So I'm using this number of moles. So 1785.7 mole of N2 will require how many moles of H2? That will be 3 into 1785.7. It comes out to be 5355.9 moles of H2. That means this quantity of N2 will require 5355.9 mole of H2. Now just analyze our data. We require 5355.9 mole of H2 that will react with 1785.7 mole of N2, but in question we were given with only 5000 moles. Now for this number of moles of N2, I got this number of moles of H2 that will completely react with, but in question we were provided with only 5000 moles. We were required 5355 moles, but in question only 5000 moles were given. That means the quantity of H2 is less, which is required by 50 kilograms of N2. So that means my H2 is the limiting reactant, which will get consumed first and reaction will stop. So I'm writing that H2 is limiting reactant. So what next? Now I have to evaluate the product. So now let's talk about the product. My H2 is a limiting reactant, so with respect to H2 I will evaluate the quantity of NH3 that will be formed. So you can see that now 3 moles of H2 will produce 2 moles of NH3, and I'm going to use this relation to find the amount of NH3 that have been formed. So I'm writing beta 3 moles of H2 produces 2 moles of NH3. 2 moles of NH3. So what was the quantity of H2 given in the question? That was 5000. Then obviously this quantity will get consumed first. So this quantity will produce how many moles of NH3? I'm going to use this and it comes out to be 5000 moles of H2 will produce now how many moles of ammonia? That will be 2 divided by 3 into 5000 moles of NH3, and it comes out to be 3333.3 moles of NH3. Now that's the number of moles of NH3 that will be produced in this reaction. So it will be obviously the weight of NH3 divided by molecular mass of NH3 will be equal to the 33.33. So what's the molecular weight of NH3? It comes out to be 17, that is NH3. The atomic weight of nitrogen is 14 plus that of hydrogen is 1 into 3, and it comes out to be 17. So I'm multiplying 17 into 33.3, and it comes out to be 56.6 grams. My initial values were in the kilograms. So I'm going to find the value of NH3 again in kilograms. So that means divided by 1000, it comes out to be 56.6 kilograms. So I got the quantity of NH3 that will be produced in this reaction, and I have found this with the help of quantity consumed in the quantity consumed of the limiting reactant. So that was my topic for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear doubts, he can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Please don't forget to press the subscribe button. Stay blessed.